this video, I'm going to talk about how to solve SAT math problems involving parabolas. First off, I'm going to just introduce parabolas, talk about the formulas you use, about constants, that type of thing, and then I'm going to solve 3 of the hardest math SAT problems that involve parabolas, in my opinion, and the tricks that I use in order to be able to solve them. So if that's what you need, then keep watching. Okay, so let's first talk about parabolas and get some basic theory behind them before we go into the 3 problems. So I'm going to create a graph here with the basic parabola. Let's do that. Got a point going through the x-axis there, and obviously we've got a point going through the y-axis there. So let's talk about the basic parabola's form. You can see that up there in the top left of the screen. And so you have y equals ax squared plus bx plus c. And so let's talk about the parts of this formula. You have x, you have y. So for every version of x or value of x you plug in, you're going to get a certain value of y out. The constant a, let's talk about that. So constant a is going to tell you the shape of the parabola, which direction it points. If a is positive, then your parabola will point upwards. If a is negative, then parabola will actually face the other direction. If a is greater than 1, then the parabola will tend to get squeezed. Or when I say that, I mean greater than 1 or less than -1. If a is in between -1 and 1, then the parabola will tend to widen like that. So now let's talk about C. B does play, of course, influential roles. However, in the SAT, you don't necessarily need to know too much about it. C is always going to be this value right here. Whenever x is 0, you can see in any parabola that you plug 0 in to x, C is going to be the only thing left over. So let's go ahead and talk about how you would solve for the x-intercept. So every parabola can be broken down into a form such as this, where you have 2 variables, 2 values right here. And each of those values are going to be the opposite of what is the x-intercept, because if you plug the x-intercept in for x, then it'll be added, subtracted to its opposite, and the whole equation will become equal to 0. So it's important to remember that. That's a quick way to solve when you're using parabolas. However, there is a more complicated equation, which is -b plus or minus the square root of b squared minus 4ac divided by 2a. And you can use this equation plugging the values of a, b, and c that are listed in the upper left-hand corner of the screen. You can plug each of those in to that equation in order to find the 2 possible values for the x-intercept. And you can also use this equation to find the solutions if a line is passing through the parabola, for instance, and that's oftentimes the type of equation or problem you have to solve in the SAT. One other thing that's worth mentioning when we're talking about parabolas is how you find the vertex. You can always put parabolas in a form such as this. And as you can see here, again, there are blanks like there were in the problem up above, right there and right there. A is the same value as the A up here. X, or, well, the value that's beside X, the unknown value right here, is always going to be the opposite of the X value of the vertex of a parabola, which, just so you know, the vertex would be approximately right there. It's right where the direction of the parabola turns, and then also this value right here would be the y coordinate of the vertex of the parabola. So the x, the open space here is the opposite, and this value is the actual y coordinate, because if you end up plugging the x value of the y coordinate into this equation, again, it'll cancel out and it'll leave you only with the y coordinate left. However, one thing that's important to note is you are not having to use all of these equations every single problem that involves parabolas. It is nice for you to know each of these factors and how each of the constants can affect a parabola, especially knowing how to use this equation up here is very necessary. In the following 3 problems I'm going to do, I'm going to be using some of these facts, using some of these things in order to be able to solve them. Oftentimes, honestly, I'd say about half of all SAT problems involving parabolas, you can simply plug the equation right into Desmos. However, you can't always do that. So I'm going to cover 3 problems that you can't do that, and therefore are probably some of the hardest problems you'll see on the SAT using and involving parabolas. So here's the first one. In a given equation, k is an integer constant. If the equation has no real solution, what is the least possible value of k? So we're trying to find a solution for k, and let's go ahead and just multiply this equation out. So erase that. We have kx squared minus 56x, and let's move 16 to the other side, set it all equal to 0. So based on this, you can see that it is indeed a quadratic equation because we have x squared in the problem. And there are several ways you can solve for quadratics, as I already mentioned. We're not going to use the factor version because we have a constant and we can't factor that. However, we can use the equation that was like negative b plus or minus the square root of b squared, etc., in order to solve. So there's a trick behind this when you're trying to solve for a problem that has no real solutions. You don't actually have to do that whole formula. All you have to do is figure out when b squared minus 4ac is less than 0, because if that's the case, then because all of this is under a square root in the equation, then it's going to be undefined. There's no real solution because you cannot find a solution for a square root that has a negative number inside of it. So all we have to do is solve for that portion. And again, going back to our original formula, along these lines, we can find the values of a, b, and c. So we have 56 squared, or negative 56 squared, minus 4k 16. And this is where I'd plug this into Desmos and see when is equal to 0. And after that, we can figure out what's less than 0. So let's go and plug that into Desmos now. Okay. So we got negative 56, which you could actually just put in there as positive 66 or 56, because it doesn't matter whether it's negative or positive. When you're multiplying 2 negative numbers together, they're automatically going to be positive. But we'll go and put that in there just because. And then we have 16. So we have 49 is our answer here. It's equal to 0. So we go back over here. We have 49 is our answer for k if it's equal to 0, but we know this equation must be less than 0. So it's actually going to be one integer, because this answer has to be an integer, it's going to be one number greater, it's going to be 50, because then the whole equation is going to be forced to be less than equal to 0, because suddenly this part of the equation is going to become bigger if you have 50 in there instead of 49. You can do basic multiplication to figure that out. So in this problem, our answer is going to be 50. Okay, our next problem here, very similar, except they're calling for one distinct real solution instead of no solutions. So let's go ahead and read the problem. In the given system of equations, k is a constant. The system has exactly one distinct real solution. What is the value of k? And you've got these 2 equations up here. So let's go ahead and get these into a simpler form, add them all together. We want to get rid of y because we want to be able to set everything equal to 0 like we did in the previous problem. So let's multiply the entire bottom equation by a negative number and then add them together. So that means you're going to have 2k equals x or negative x squared plus 6x plus 26. And let's go ahead and move 2k to the other side here. So we go minus 2k, set the whole thing equal to 0. And again, we have that problem from before, except when you have one distinct real solution, let's go back to our original page. If you're going to have only one solution here, how do you do that? Well, this part is going to have to equal 0, because if that happens, then you're plus or minusing 0, adding or subtracting 0, which means that all that's going to matter is the negative 2b divided by 2a portion. The other part won't matter, so we just want to set that other part equal to 0 instead of being less than 0 like we were doing before. So b squared minus 4ac equals 0. So let's go ahead and plug those pieces in again. Got 6 squared minus 4 times negative 1 times 26 minus 2x or 2k, whatever you want to put in there. Let's go ahead and plug that into Desmos now. So we've got 6 squared minus 4 is negative 1 times 26 minus 2x. Got 17.5. So that means 17.5 is going to be our answer. Before I move on, I just want to encourage you to like and subscribe, because this is a part of my college application process, and you can help me by engaging with my channel and helping me monetize my channel and pay for college. Especially if you've enjoyed this video, you can find a lot of other great similar videos on my channel that tell you about how I was able to raise my SAT score by 220 points. So please subscribe. Last problem. Let's go ahead and read it. The function f is defined by f of x equals ax squared plus bx plus c. So that's our standard parabola form, where a, b, and c are constants. The graph y equals f of x in the xy plane passes through the points 7, 0, and negative 3, 0. If a is an integer greater than 1, which of the following could be the value of a plus b? So let's go ahead and write this out. We know that a is going to be greater than 1, it's an integer. And then you have your x-intercepts at 7, 0, and negative 3, 0. So it means it's approximately going to be like this. And because we know that a is greater than 1, we know that it must point upwards, something like that. It says what the following could be the value of a plus b. So let's go ahead and create a form. We know that when you factor out a problem, you factor out using when you factor out a parabola, you factor it out using its x-intercepts. So approximate form of this could be something like this. Because if you plug in either 7 or negative 3 into this problem, then the answer is going to be 0 coming out. However, the important thing to note is that if you multiply this out like this, then a is not greater than 1. It's just 1. And so you multiply the entire thing by a so that it's still equivalently the same. The factors are still the same. However, you now have an a constant that is greater than 1. So that's how you figure that out. Let me go ahead and erase some things so I have a little bit more room to work here. Okay, so now let's take the form we have up here and try to figure out what a and b might be equal to in the problem down below. So you've got ax squared minus 4ax minus 21. Got ax squared plus bx plus c. Now, these forms are going to be somewhat equivalent to each other. You have ax squared equals ax squared, right? These two forms are equivalent. These two forms are equivalent. These two forms are equivalent. And so you can cancel this out. Just see it's 1-to-1 ratio. We've got negative 4ax equals bx. So that means negative 4a equals b. And we don't need to know c because all you have to know is a plus b. So that means, in this context, a minus 4a, which you see here is b, is going to be equal to negative 3a, right? And the thing here is we know that a must be greater than 1. So it can't be 5 because you would have to have a negative number in order for negative 3a to be 5. It can't be 4 because same thing, you'd have to have a being a negative number. Right here, a would have to be 1 in order for a negative 3a to be the value of a plus b. Also not the case because it's greater than 1, so a must be our answer. A is the answer to the problem. I hope you found that video helpful, and if you did, then please like and subscribe. If you have any questions or ideas for future videos, leave those in the comments below. If you have any math problems or English problems that you'd like me to solve on a video, then I can do that as well. Just let me know what number they are in Blue practice tests, and I can do just that. I got a 790 on English and a 780 on math on the digital SAT, and I'm here to help you guys. So yeah, I hope you enjoyed this video. I hope it helps you to be able to get more of those parabola SAT math problems right, and I'll see you again soon.